illnesses. Okay, and so what are the primary illnesses and what are the characteristics of these illnesses? So really that comes down to there are two main types. We've got frostbite and we've got hypothermia. And so frostbite actually starts with frostnip. Okay, and this is where your skin starts to change colors. It doesn't go very deep. It's kind of like a first-degree sunburn. It's reversible, right? And so it might look something like this. It might not, but just think of it kind of like the cold version of just a basic sunburn. Okay, so first-degree sunburn, that's how I remember these and how I think about these. Then we've got superficial frostbite. This is kind of like second-degree sunburn. Okay, obviously the physiology is different, but you're starting to damage the tissue all the way down to the subcutaneous fat. You might get blisters. The tissue might be okay, but because you've got the blisters and the exposed tissue when they break, could get infection and could get a little nasty, I guess, for lack of a better term. Okay, not great. But with second-degree sunburn, you also get blisters, right? Then we've got frostbite, deep frostbite. This is where we get into permanent tissue damage. Okay, this is where skin starts to turn black. This can get down even to the bone, to the muscle. Okay, so this is when you're getting very, very cold. And really the tissue is getting cold. Kind of a lighter version of thinking about this. What I mean like this is if you've ever seen the Adam Sandler movie Mr. Deeds, right? He had a black foot because something about a pond or lake playing hockey, and his foot turned black. Obviously, what is depicted in that movie is not what happened in real life. You just wouldn't have a black foot for the rest of your life. Okay. It can get bad enough that you have what's called spontaneous amputation, where body parts just fall off. Now, generally speaking, frostbite and all this occurs in the extremities. Why? Because we have that vasoconstriction, right? So to try and maintain core body temperature. Remember, at the end of the day, the goal is to survive. Like I can survive without a hand. Not great, but I can. Okay, and so it's one of those where you're, risk reward, I guess. So I'm willing to give up a hand if it means I survive. So this occurs when the tissue is freezing. Okay, so you don't get frostbite in temperatures that are above freezing. Like can't happen because nothing's frozen. But then we get hypothermia. So hypothermia occurs when your core temperature drops below 35 degrees Celsius or about 95 degrees Fahrenheit. It can get worse than that. Body temperature can drop below 28 degrees. Generally speaking, though, most people survive some pretty extensive hypothermia. So 32 degrees Celsius, which is a drop of about 5 degrees Celsius from normal, most people, 9 out of 10, survive, right? It's not something I want to risk, but odds of surviving if your core temperature drops that low are pretty high. So how does it work, or how long does it take to kick in? And the answer is, well, it depends. How cold are you? How cold is the air? It's all about gradients, right? How many times have I said that this semester? It's all about gradients, and we're going to talk about gradients with the altitude unit as well. Okay? When ambient temperature gets to 65 degrees, that's where you have the risk for hypothermia. But it takes a really, really, really long time, right? 65 degrees, that's my jam. I love it. That's great weather. I don't think it's cold. I don't think it's hot. I think it's just right, okay? If I were to stay outside, not do a whole lot in 65-degree weather, that could be a problem. But this is something that would take hours or days to really be a problem, okay? Now, if the gradient is 60 to 70 degrees. Now remember, this is Fahrenheit here, so don't get confused. This is Fahrenheit and this is Celsius. Okay, the gradient. Okay, your body temperature is normally at 98. So when we're talking about a gradient, we're going to say outside is 28. Okay, 38 to 28. That's when you can start to experience hypothermia in an hour. Now, if the gradient's 100 degrees Fahrenheit, so now we're below 0 degrees Fahrenheit, that can occur very rapidly, minutes. What can even make this worse is that cold water immersion accelerates the onset. So why does that happen? Why does cold water make hypothermia or increase the likelihood that hypothermia occurs? Well, it has to do with convection. Remember how we talked about convection the heat transfer of convection is much higher in water than it is in air. So, well, if you experience hypothermia, what's going on? When your core temperature gets to about 35, so that's kind of the cutoff, be confused, maybe a little lethargic like it says. You're going to start shivering, or hopefully you've already started to shiver. If you get a little bit colder, you start to experience amnesia. If you get even colder, this is where you start to go in and out of consciousness. Your pupils become dilated and fixed. And then if you get really, really cold, you become unconscious, breathing stops, you don't have reflexes. Okay? Now, it is possible for people to get really, really cold and come out of this. All right? And then even with cold water immersion, this makes it worse, or it can accelerate the process. Basically, what happens is your body's shutting down. And because it just kind of shuts down, that actually can be what saves your life if you're in one of these extreme, if you have, for some reason, you have an extreme drop in temperature. So if a subject or a person is experiencing hypothermia, you need to get them warm, right? Like, that's the thing. Get their wet clothing off and help them to drink warm, not hot, but warm water. Okay, we don't want to rub the body with warm water, we don't want to warm them by, you know how you rub your hands when you're cold. You don't do that because that can actually cause tissue damage because they're going to be cold. And if they're experiencing hypothermia, odds are they're in an extremely cold temperature. And the tissue could be, especially on the surface, could actually be frozen. You want warm water baths, like 34, 35 degrees Celsius. That's high 80s or 90s. So it's not really, really hot. If you get much warmer than that, you can cause heart damage, but it's enough to warm them up. Okay, and it's unlike cold water where we want to cool them off as quickly as possible. That's not the case for hypothermia. It can cause a lot of damage if you warm them up too quickly. So what causes someone to get hypothermia? Well, if you've had hypothermia once, you're more susceptible to get it again. This is something that happens, I would say, especially in the spring and the fall when you're kind of in that transition period. I mean, just imagine, so it snowed last night, right? And if you weren't prepared for it and got in a wreck or whatever, heaven forbid, right? Odds are you weren't prepared for it. And then obviously if you're in a blizzard and in the middle of nowhere, you can be there for a long time. And then the one that I think is potentially the biggest one, it's one that I think of because I used to spend a lot of time backpacking and camping, is that, let's say you're out in the back country and you fall into the creek or whatever. Okay, it could be a beautiful day, but those mountain streams are really cold. And so now you're wet in cold water. Even though it's hot outside, it's not terribly difficult to experience hypothermia. And with that, we are done with our cold unit.